Figure 1 gives a cubic curve, y equals x plus a times x minus b all squared. A and b are positive constants. Curve cuts the x-axis at P and has a maximum point at S and a minimum point at Q. Write down the coordinates of P and Q in terms of A and B. So this will have roots. This will equal 0 when y is equal to 0 when x is equal to minus a or b. And we're told that a and b are positive constants. We can also see the repeated root is right here. So this here is going to be minus a, and this is going to be b. Therefore, p is minus a 0, and q is b 0. Now asked to show that G, the area of the shaded region, as shown, is given by this. Okay, so this is going to involve an integration. It's going to be the integral from minus a to b of this curve, x plus a, x minus b squared. That's a very quick way of doing this integral, and there's a very inefficient way. And guess what? I did the inefficient way when I did this question. I don't know, just expanded it out and integrated it. But you can see that's going to be complicated because look at the answer. So you've got to think about a quicker way to do it. And although it might not seem immediately obvious, this is actually a product of functions, and we can use integration by parts. So I'm going to call this one v dash and this one u, because it's going to, when I differentiate this, it'll be then quite nice and simple. So u dash will actually just be 1, because remember a is a constant, so I'm just differentiating x plus a to get 1. And then v is going to be the integral of x minus b all squared. This is going to be 1/3 x minus b cubed. So I get uv evaluated between b and minus a, then minus the integral of from minus a to b of u dash v. This is going to become x plus a multiplied by 1/3 x minus b cubed. And then minus the integral. U dash is just 1, so it becomes 1/3 x minus b cubed that I need to integrate. And I'm gonna substitute in and then integrate this one at the same time. So when I substitute b in, I get 1/3 b plus a. Then over here I get b minus b cubed. So actually this term cancels. And then I substitute in a, well, sorry, minus a. It's going to actually cancel as well, because I've got minus a plus a here. So I'm left with the minus, and then integrating this, I'm now going to divide by 4, so it's going to become 1/12 x minus b to the 4. Minus 1/12 b minus b to the 4 minus 1/12 minus a minus b to the 4. This again cancels, so I'm left with 1/12 minus a minus b to the 4. Now, because this is the fourth power, it's actually exactly the same as having a plus b to the 4. And if I had, say, minus 2 minus 3 to the 4, then that would give me minus 5 to the 4, which is the same as 5 to the 4, which is the same as 2 plus 3 to the 4. We can do this for any a and b. We don't need to prove it. That's, it's just a fact. So we've managed to derive the answer. There it is. That is the shaded, I didn't actually say at the start, did I? But that is G, the shaded region. Good. I haven't considered it. I'm going to refrain from showing you the solution where you expand the whole function out. By all means, give it a go. The official solutions do comment on it, but you just end up, it doesn't really give much insights and it's just like not a good method. So it's not always good to just show a method that's not any good. We end up with lots of terms, we integrate them, we get a quartic function, which we then recognize can be factorized back to a plus b to the 4. But this one is it's just so much better. So even though I didn't think about it when I did it, I'm sticking with it now. Okay, we're then told that the rectangle PQRST has RST parallel to QP and PT and QR parallel to the y-axis. This is another way of saying there's a rectangle that goes up, across, and back down. And then we're asked to show that G, the shaded area that we found, divided by the area of the rectangle is equal to a constant that's independent of A and B. That's pretty cool. And we've got to try and show that that is true. So we can immediately see that the base of the rectangle is simply going to be A plus B, because it's B minus minus A. We can see that this bit here is A and this bit here is B. So we just need to work out the height and then we're sorted. And S, remember, is a stationary point. So I'm going to need to differentiate now. So y equals, I've actually forgotten what the function was. Was it x minus x plus a times x minus b squared? So let's find dy by dx. And again, I'm definitely not going to expand it this time. And I didn't at the time. I really don't know why I expanded it originally. I just did. So we can use the product rule here. U dash is going to be 1 again, and v dash is going to be 2 times x minus b. So we've got u dash v plus u v dash x minus b squared plus x plus a times 2x minus b, and this will equal 0 for stationary points. Now there's a common factor of x minus b that I can factorize out, so x minus b multiplied by x minus b plus 2x plus 2a. So it's 3x plus 2a minus b is equal to 0. So either x is equal to b, which actually we've already accounted for. That's right here. This is our position of Q. Or 3x is going to equal b minus 2a, meaning that x is b minus 2a over 3. And this is the position of s in terms of x anyway. So remember, we actually want the y value because that's going to be the height of the rectangle. So when x equals b minus 2a over 3, y equals b minus 2a over 3 plus a multiplied by b minus 2a over 3 minus b squared. I'm going to continue to simplify it. At the time when I did this question, I didn't bother, but I think it's just good to simplify things as you go quite often. So I can rewrite a as 3a over 3, which means I'll get b plus a over 3 here. And I can rewrite b as 3b over 3. And then over here, I'll get minus 2a minus 2b over 3 all squared. I might bring out the 1 over 27 because I'm going to I've got a 1 over 3 and a 1 over 3 squared, so 1 over 27, b plus a, and then this will become 2a plus 2b. Just like before, I can just get rid of the negative. And I can actually factorize out the 2 from here. But remember, I'm factoring this out of both the brackets. This is 2a plus 2b times 2a plus 2b, so I can factorize out 4 to give me this. All right, that's looking pretty good. In fact, I think we're probably nearly there. So that means the area of the rectangle is going to equal 4 over 27 times a plus b to the 4, because remember, the base was actually a plus b. And therefore, G over the area of PQRST is equal to 1/12 a plus b to the 4 divided by 4/27 a plus b to the 4. These just really nicely cancel. 1/12 times 27 over 4. I can divide through by 3, so this becomes 4 and this becomes 9, which gives me my final answer, 9 over 16. I really like that. So you can change a and b whatever we want, but the fraction of the shaded area when we construct this triangle will always be 9 over 16. Really, really nice.